guys, welcome back. So what we're looking at today is lesson 6, similarity. So let's go ahead and jump right into this. So similarity transformations part 1. So similarity of transformations basically means that there's a sequence of transformations, whether it be reflections, rotations, and dilations, that takes one figure to another figure. So if we look at these two figures here, obviously there's a definite dilation going on between these two figures. We also have a rotation and a translation to take and move this original figure over to this green one, so the blue to the green. We have these transformations. We have this sequence of transformations. So more than one sequence of transformations that shows two figures are similar. So there's different ways to take and do the sequence of transformations. We can do them in multiple orders sometimes. So for number 1, triangle EGH and triangle LME are similar. Find a sequence of translations, rotations, reflections, and dilations that shows this. So if we start with our smaller triangle, now we could start with either or, it does not matter. If we start with our smaller triangle, we can translate L to E. So translate L to E. So that moves it up so they're in the same position, but obviously LME is much smaller than EGH. So the next thing we need to do is dilate using E as the center of dilation because we want it to be in that exact same place. We don't want it to take and dilate from an external point. So dilate LME by, how much do we need to dilate by? This side is 2. This side is 1, 2, 3, 4. So dilate it by 2 with center E. So that will take and transform this. Now, we also could have done our dilation first. We could have shrunk it down and then moved it down. We could have done that. It doesn't matter. So like I said, there's multiple ways to go between these two figures. And it's just that sequence of transformations. We can have more than one that will get them between. But with the similar means that we can do these transformations. So they're not congruent because the sides aren't the same. They are similar instead because there's the dilation involved. So our next one is we have a hexagon. Maybe if the screen will move. Oops. Oh, gracious. A, B, C, D, E, F, and hexagon H, G, L, K, J, I, and they're similar. What we want to do is find a sequence of translations, rotations, reflections, and dilations that show this. So once again, there's multiple ways that we can do this. There's not just one set way that we have to take and do this. So let's start with the smaller one. So if we start with A, B, C, D, E, F, we can take and reflect it over a line. So we want to make it, because obviously this one is facing this way and this one's facing the other direction. So reflect, I don't know why my pen didn't work. Reflect A, B, C, D, E, F over. Now, in order to take and reflect this over, we need to have a line to reflect it over. Since we want this part over here, the DE, to end up on this side, we can reflect it over the line AF. So reflect over AF. That can be our line, rather than making an external line for it to reflect over. Then, so now it's facing the other direction. So we have it looking something like this. Obviously, that's not exact, but we have it facing this way. Now, the next thing we want to do is translate. So move this point F down to its corresponding point over here, point I. So translate F to I. So that's going to move this all the way down over here. So we have what looks like this, approximately. Obviously, my drawing is not exact. It's just an approximation. And then the last thing we need to do is dilate this. So we need to make this a lot bigger. Obviously, this is really small compared to this. Now, If we were to measure this, we'd find that figure or hexagon HGLKJI is 3 times larger than ABCDEF. So next is dilate by 3 with center I, because once again, being as they share this point, we want that to be the center of dilation so that it grows to become the exact same shape rather than using an external point. Okay? So that is what similarity is. So similarity is having shapes that are the same shape, but they are different sizes. And we can use different transformations to get between these shapes. So similar is your key word for this lesson, similar. If you guys have any questions, feel free to ask.